Good day, good day, good day, good day, good day. Greetings to everyone. Yes, sorry about that. How are you all doing? How is everyone doing? Welcome to this special day on a beautiful Monday. We are looking at maths for grade 11 June exams 2018. We have already prepared the grade 12s and we hope for the best for your marks as maybe they are coming out and their reports are coming out. But we are done with the grade 12s for June preparations. But now let's prepare for the grade 11s. I think they are writing sometime this week. So let's equip each other and let's see the important aspect which we can tackle so that when we are writing, we can pass and have the marks which we are all wishing to have. Okay. What is important is that we must also understand that when we have our questions, please don't hesitate to ask on the group so that we can assist each other. And also, please don't forget that you can subscribe for us. You can also comment on the comment section as well as to share what you think and what your problem might be. On the description of this video, you will see the WhatsApp link that you can use to join our WhatsApp group. Then you'll be able to receive some materials to use when you are practicing your exams. Okay, great. Now let's get down to the business of the day. So here I have Gauteng Department of Education June exam, grade 11. So it comprises of 100 marks. So it has 100 marks. So we're gonna try to do everything on this paper. It's only 100 marks, so at least 100 marks you can do it in 1 hour, since now we have all the background of everything which we need, of all the important concept which we need to know. So this is the question paper. As you can see, it comprises of 6 questions. So we'll try to do as much as we can and we'll enjoy it together. The idea is for you to understand and for you to have the background of what you are supposed to expect when you are writing your exam on maths paper 1. All right, great. So now, looking from the first question which is question number 1. Now let me just give you 2 minutes so that you can prepare and just share the link as well so that other people can join as well. Okay, so that we can have some fun. Let's 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 have some fun. 6 questions. So we'll try to do as much as we can. Okay, great. Let's hit the road. Let's hit the road then. Let's have some fun. Great. Determine the values of question 1. Determine the values of x for which the following expressions are defined. So for instance, now bear in mind that what we are doing here, we are revising for our June exam. So let's have some fun together. Okay, great. Now, first question, determine the values of x for which the following expressions are defined. So what we must know, or what we must understand, is that what does the question want? So as I always say, that you must be able to conceptualize before you answer your question. You must have the background of what do you need to know before you answer your question. So for instance, in this particular question, they said determine the values of x for which the following expressions are defined. So you must underline or highlight the key terms which are given in this specific or question. So great. On 1.1, so they're saying that determine the values of x for which this following expression will be defined. So let me just do this. Create note. That also gives something. Great. Okay, right. Here we go. Okay. So the first one says when square root of x minus 3. So this expression 1.1.1, it will be defined if, let me just write it, x minus 3, it will be defined if x minus 3 is greater or equal to 0. So x will be greater or equal to 3. That will be our answer. Okay, so this expression will only be able to be defined when x is greater or equal to positive 3. Bear in mind that we are sort of like looking at the domain of these specific functions. So e.g., let me just say e.g., we are given the function f of x equal to square root of x minus 3. So when they say determine the domain of this function, in other words, we are wanting to know on which values or of x will this function be defined, or on which values of x we will be able to locate our graph of f of x. So in this instance, we will have f of x equal to square root of x minus 3. So you take what is under the square root, then we use the inequality greater or equal to 0. Then therefore our x must be greater or equal to 3. The next one says that 1.1.2, the values of x for which 1 over x minus 3 will be defined. So in your mind, have the mindset, or think of like a hyperbola. So when we are determining the domain of a hyperbola, so let's just say let f of x be the hyperbola, which is equal to 1 over x minus 3. So when we are looking at this in the perspective of having that this is a hyperbola, we know that we look at the denominator. So what do we say? We always say that x is the element of real numbers, where x will not be equal to 3. So you equate this to 0, then after that it must not be equal to 3. So definitely this expression will be defined only if x is the element of real numbers and x is not equal to 3. Then after that you have your 1 mark. Okay, that's that, and we are happy and everyone is enjoying. Great. Now on 1.2, for which values of x will k equal to square root of 3x minus 1 over x minus 1. So on number 1.2, how do we solve this? So we are given that k is equal to square root of 3x minus 1 over x minus 1. So what I'll definitely tell you to do is that you must be able to understand two things: that you must understand what's on the numerator and also what's on the denominator of the square root. So we know that up on the denominator, x minus 1 must be greater than 0, and also on the numerator, 3x minus 1 must be greater than 0. So when we are solving this, we're gonna have x is greater than, just use here, let me just say, then x will be greater than 1, and also x will be greater than 1 over 3. So these are the two x values. So which one is smaller than the other one? 1 over 3 is smaller than the other one. So they are tending, or the x values must be the element from 1 over 3 to positive 1. Then we get our x values, and we have solved that problem. Now on 1.3, solve for x. Now we are solving for x. So this is easy, as you always know. So when you're solving for x, whilst we are already given factors, what do? We equate them to 0. So x plus 1 multiplied by x minus 1 over 2 is equal to 0. So since we are already given factors, or since they have already solved the quadratic equation, so it's gonna be x plus 1 is equal to 0, or x minus 1 over 2 is equal to 0. Then we solve for x by transposing 1 to that other side. So when you transpose 1, it's going to be negative 1, or x will be equal to positive 1 over 2. Then you get your 2 marks, just like that. So you can see that maths is easy. So 1.3.2, so we are given x squared minus plus x minus 1 is equal to 0. Then they said in brackets that correct to 2 decimal places. So the moment they say correct to 2 decimal places, your mind must write that, oh, okay, 2 decimal places, which means you don't have to solve anything. You don't have to try to solve for factors. You just have to go directly and use the quadratic equation. And the quadratic equation says that x will be equal to negative b plus or minus square root of b squared minus 4ac all O divided by 2a. So we know that 1 is our a, 1 is also our b, then this is our c. Then now we substitute, so we're gonna have negative, what is our b? Our b is positive 1, so negative 1 plus or minus square root of 1 squared minus 4a, and our c, it's negative 1. Our c is negative 1, then we divide all together by 2 times A. Okay, then after that we use our calculator. So let's use our calculator now so that we can get the x values, so that we can get the values of x. Let's use our calculator right now. So the fact that they say that correct to 2 decimal places is what led us to just use our quadratic equation. So now we can therefore see that my first x is equal to 0.62, or my second x will be equal to negative 1.62. So these are my x values. Then you get your 4 marks just for that. You must be able to round off to the nearest 2 decimal places. So if you write 5 here, then your answer is going to be wrong. If you write 4 here, it's going to be wrong because they told you that you must round off to the nearest 2 decimal places. Okay, now let's move on and do number 1.1.3. 1.1.3, that's an inequality. So 1.1.3, we are given x squared minus 2x plus 1 must be less or equal to 0. So as always, I always urge you to write that you are solving for critical value, so that you can be able to equate your equation to be equal to 0. Then now we can actually find factors of this. Okay, so we can see that x minus 1, it must be, you can actually see that when you are finding factors, it's going to be x minus 1 and also x minus 1 is equal to 0, because negative 1 times negative 1 is positive 1, but negative 1 minus 1x is going to be negative 2x. Then therefore our x minus 1 will be equal to 0, or our x minus 1 is equal to 0. Then our x will be equal to, therefore our x is equal to 1. So if x is equal to 1, which means that now our x must be less or equal to 1. Okay, so when you're drawing or when you're writing this, we know that it's gonna be a shaded less than is this side. So here we go. So in order for us to certify this inequality which you are given, your x value must be must be greater than 1. Sorry, yes, it must be less than by 1. It must be less or equal to 1. Oh, sorry, it must be greater or equal to 1, so that it can be, so that it must be equal to 1. Sorry for that. Okay, your x must be equal to 1 so that we can have a value which is less or equal to 0. Okay, great. Now 1.3.4, we are given x plus 3 square root of x minus 1 is equal to 1. So now let's solve. Let's transpose x to that side. So 3 square root of x minus 1 is equal to 1 minus x. Okay, then after that we square both sides so that we can remove the square root. So when we square both sides, it's going to be 9 x minus 1 equal to, then this will be 1 minus x squared. So this is the same as this expanded form that you open the bracket so that you can simplify in a manner that you can definitely understand as well. So this 9 times x is 9x, 9 times 1 is negative 9 equal to 1 times 1 is 1, 1 times negative x is negative x times 1 is negative x. Okay, the negative x times negative x is positive x squared. Then now, as always, let's group the like terms. 0 will be equal to x squared minus 2x minus 9x plus 1 plus 9. Then we'll end up having x squared minus 7x plus 10. Then now we can find the factors, since now this is now a quadratic equation. So you can actually also use the quadratic formula from this step if you can't find factors. Okay, you can use the quadratic formula or you can use the factor form so that you can get the x values. So we have x, we also have x here. So 10, it makes up of 5 and 2. Now let me just double check something here so that I don't see that I didn't do any mistake. Okay, great, 1x. Okay, 9x minus 9, transpose that 9 to that other side, then negative 2 minus, this is negative 11. Sorry for that. So if it's negative 11, okay, it's going to be x, then we have 10 and 1, negative and negative. So then therefore we can actually see that solving this is now x minus 1 is equal to 0, or x minus 10 will give us 0. Then our x is equal to 1, or our x is equal to positive 10. Then since this is a question which has a square root, please, I urge you that you double check your answers which you receive here, which you have here, so that you can conclude which one is the correct solution. So let's start with 1. So 1 plus, let me just use a different pen. Here we go. Correct. So 1 plus 3 square root of 1 minus 1 is equal to 1. Is this true? 1 minus 1 is 0. Square root of 0 is 0. 0 times 3 is 0. So 1 plus 0 is equal to 1. So 1 is correct. Now let's try to use another value which we get, which was 10. So 10 plus 3 square root of 10 minus 1. Is it equal to 1? 10 square root of 10 minus 1 is 9. Square root of 9 is 3, and 3 times 3 is 27. 27 plus 10 is 37, and 37 is not equal to 1. So then therefore now you can definitely conclude that therefore your x is equal to 1, and or your x is not equal to, okay, show that x is not equal to 10, because you proved that by substituting the x value into the original equation. Okay, says every time when you get this kind of a solution, when you're having a square root, please don't hesitate to solve these problems. The first step is that you transpose, then after that you remove the square root. How do you remove the square root? By squaring both sides, so that you can have the correct solutions. Okay, then we can definitely enjoy from there. Now let's do the next question. Oh, great. So now on the next question, on 1.3.5, we are having 3 to the x plus 3 to the power x plus 3 to the power x is equal to 3 to the power 4. And it's 3 marks. These are exponents. So just to give you a small recap on exponents, we know that on exponents we have laws which are approximately 7. The first law is when we are multiplying the exponents of the same base, we add the exponents, and when we are dividing the exponents of the same base, we subtract their indices. Okay, so let me just write them now. So if we have a to the power m times a to the power n, this is the same as m minus n. And if we are having a to the power m divided by a to the power n, we now have a plus m. So we have m minus n. Then when you are having a to the power negative n, this is the same as 1 over a n. Then when you are having a over b to the power n, this will be the same as a n over b n. Then we also have a to the power of 0, which is equal to 0. So you must always know these laws of exponents by your fingertips, so that when you are writing in the exam, you can be able to apply them when you're having your exponential functions, when you're solving your exponents instead, so that you can actually get a correct answer. Okay, so please try by all means that you use this format, so that in due time you have the correct solution. Okay, so now in this instance, now we can see that we have a common factor, which is 3 to the power of x. So this is our common factor, so it's going to be 1 plus 1 plus 1 is equal to 3 to the power 4. So 3 to the x will be the same as 3, which is equal to 3 to the power 4. So also you can see here, let me just use these times. You can see that these two bases, let me just do this, okay? So we can see these two bases, they are the same. So it's like this. So these bases are the same. So we add the exponents and we keep the base. Is equal to 3 to the 4. So definitely x plus 1 is equal to 4, and our x is equal to 4 minus 1. Then therefore we'll get our x to be equal to 3. So to recap on this question, so how did we solve it? So we started by looking at the laws of exponents, which we know that they are approximately 6 or 7. So now after that, now we solved. So we were having 3 to the power x plus 3 to the x plus 3 to the x equal to 3 to the power of 4. So what do we do first? We say that we start by looking at the common factor. Since we can see that 3 to the power x is the common factor in all these general terms, so we take it as a scalar multiplier or as a common factor. Then now we say 3x divided by 3x, then it's 1. 3x divided by 3x is also 1. 3x divided by 3x is equal to 1. Then now we add the like terms. 1 plus 1 plus 1 is equal to 3. Then now from this step, we can see that 3 and 3, they are of the same base. So according to the laws of this exponents, if they have the same base, what do? We add the exponents. Okay, so we add the exponents and we keep the base. So that's what we did here. We added the exponents x and 1, then we kept the base, which is 3. Then now we can equate the two. Since they are both equal to 3 and 3, then we can equate, then we can get x is equal to 3. So also another alternative method. So if you arrive here, so someone was gonna say that, oh, okay, I have 3x, then you divide both sides by 3. It's also a good method. You divide both sides by 3. So we have 3 to the power x is equal to 3 to the power 4 minus 1, because when you divide the exponents of the same base, you subtract the exponents. So 4 minus 1 is equal to 3. Then therefore your x is equal to 3. So you can use option 1 or option number 2 when you're solving for your exponents, right? So just to highlight again, once more again, when you're solving for your exponents, the first thing which is so crucial, or the first thing which is so important, is to understand that you must remember or recall, or you must know all your laws of exponents by your fingertips, so that you can be able to apply them when you are writing as well. Okay, great. Now solve x and y simultaneously. Okay, 1.4. Solve x and y simultaneously. So now we are on 1.4. That now they are telling us we must use the simultaneous equation. Okay, let's solve together. Great. 1.4, x squared plus 2xy is equal to 3y squared. Then from the word go, write it as equation 1. Then 2y minus x is equal to 6. Then write it to be your equation number 2. Now let's solve it together. So now let's make equation 3. So 2y minus 6 is equal to x can be our equation number 3. Then let's substitute 3 into 1. Okay, substitute 3 into 1. So wherever we see x, we're gonna put 2y minus x. Okay, so in this instance, we're gonna have 2y minus x, or squared, plus 2y. Then on that position of x, we replace with 2y minus x is equal to 3y squared. Now let's go. 2y minus 6 squared is the same as 2y minus 6, and 2y minus 6 plus 4y minus 12y equal to 3y squared. Then 2y times 2y is 4y squared minus 12y plus 36 plus minus 4y minus plus 4y squared minus 12y is equal to 3y squared. Now grouping like terms, so we're gonna have 8y squared, because we have 4y squared plus 4y squared, which is 8y squared. Then we subtract that 3y squared from the right hand side. Then negative 12 minus negative 12 is negative 24, minus negative 12 is negative 36y. So you use your calculator so that you don't do any mistakes. Then we have plus 36 is equal to 0. Then now we have our 5y squared minus 36y plus 36 is equal to 0. Then now, since it's like big numbers like this, I always urge you, use your quadratic formula. Use your quadratic formula so that you can get the 2x y values, or you can find factors. So if you are like me, you can see that the factors here will be, let me just use the quadratic formula so that everyone is safe. The quadratic formula says that x is equal to negative b plus or minus square root of b squared minus 4ac all divided by 2a. Okay, Then now in this instance we are solving for y, so you put our y here, so our y will be equal to negative of negative 36 plus or minus square root of negative 36 all squared minus 4a and c. That's 4a and c. We divide everything by 2a. So this can be easy for you. So arriving from this step, so we saw that we can never find factors. It's hard to find factors, I can say. So what I'll urge you guys to do is that when it's hard for you to find factors, there is always the quadratic formula which will be there for you, which will be able to save your day. Okay, now let's move. Then let's use our calculators, guys. Let's all use our calculators so that you can get the y value. So the first y value is y is equal to 6. My first y was 6 when I'm using my calculator, or your y will be equal to 6 over 5. Great. Then now we want x. Now we substitute the y values in 3. So in question 3 was saying that x is equal to 2y minus 6. So we now in 3, which is x is equal to 2y minus 6. So let's substitute, guys. So the first x will be x is equal to 2 times 6 minus 6, or the other one will be x is equal to 2 6 over 5 minus 6. Then this will be x is equal to 2 times 6 is 12. 12 minus 6 is the same as 6. Or x will be, this will be 12 over 5 minus 6. Then we'll get our negative 18 over 5. So these are the two x values and these are the two y values. So you can actually see that it's so easy to solve for the simultaneous equation. The first thing you do is just take them as they are, then you equate them. Another one equation 1, another one is equation 2. Then the third step which you are supposed to do is to make one of the variables x or y the subject of the formula so that you can have another equation. Then now substitute that equation number 3 into equation 1 or 2. Then after that you can solve for that first variable. Then when you're solving for y, after you arrive here, when you're having a quadratic equation, now you can use a quadratic formula or you can find factors so that you can get the value. So in this instance we use the quadratic equation since we thought that we can't find factors, so we can use the quadratic formula. There is no offense by using quadratic formula. It actually gives you answers which are accurate. Okay, now let's move forward to the next question. Let's move forward, which is question number 2. Wow, great, we are moving. Question 2. So the first question of question number 2 says simplify without using the calculator. So underline that part that you must not use your calculator. Do not use your calculator. The moment you use your calculator, they will be able to see that this one thinks that is clever. You use their calculator, so they will give you partial marks or even give you a 0. So avoid losing marks on those silly mistakes. Okay, great. So now let's solve. These are sets. So when we're solving the sets, we're gonna have 3 square root of, what do we have for 12? 3 times 4 minus, so 75, it's the same as 3 times 25. Okay, then when we can multiply and do everything, we can actually see that this will be 6 root 5 minus 6 root 3 minus 5 root 3. Then 6 minus 5 is 1 root 3. So we can actually see this is our answer. So please avoid using a calculator. Okay, another trick which I can say is that you press your calculator only for this. Press your calculator for this only, alone, without everything. It's gonna give you this directly. And press this alone, it's gonna give you this also directly. So also if you do that, you can also arrive to the final answer. Okay, but this step is so crucial because, for instance, this was a 3-mark question, so you get a mark for writing this, and you're for writing this, and for writing this. So what I'll advise, if you want to use your calculator, use it step by step. Use it for only the first one, then you get this value. Then you use this one, you get another value. Okay, because if you use it automatically, they will see that you used your calculator. Of course, you're gonna use your calculator to get a correct answer, but make sure that you show the steps on how you were able to get those few answers which you have. Now, without using a calculator again, show that 2 to the power 2010 2 to the power 2.2.1, okay? So that without using a calculator, that 2 to the power 2010 plus 2 to the power 2012 is the same as 5 times 2 to the power 2010. So what do we know about these things? We know that from Euclid trigonometry, from trigonometry, that we start by solving the left hand side. You cannot balance them at the automatic set go. You can set one or the other one. So left hand side is equal to 2 to the power 2010 plus 2 to the power 2012. So that was my first step. Then from there, now let's break 2012. We know that 2010 plus 2 is the same as 2012. So since these two, they give us the 2012, so we break that down. Now we're going to apply also the laws of exponents, which we know that when we have 2 to the power something, or a to the power m times a to the power n, we get a to the power m plus n. So we're going to use this same exponential law so that we can have or we can break this other term. So we're going to have 2 to the power 2010 plus 2 to the power 2010 plus 2. So in the position of 2012, now we only have 2010 plus 2. Okay, now we know that 2 to the power 2010 plus 2 to the power 2010 times 2 to the power 2, as we have seen here that we can break these two. Okay, then when we break them, now we can see that we have the common factor, which is 2010. So it's going to be 1 plus 2 to the power 2, and 1 plus 2 to the power 2 is the same as 5. So it's the same as 5 to the power 2, 2010, which is the same as our right hand side. So that would definitely show that you were able to prove. So the first thing which we're able to do is to able to show that, okay, we can see that on the left hand side, that's where we have many variables, or that's where we can actually solve further. So we started by solving further on our left hand side. So we solved our left hand side first, then we were able to arrive here. Then arriving here, we now break down the 2012 here, applying the laws of exponents, knowing that the same bases are together and there are multiplying each other, then we can definitely get this outcome 2012. So 2010 plus 2 is the same as 2012. So we use that aspect, then we're able to get the correct answer. So now, hence, calculate the value of 2 to the power 2010 plus 2 to the power 2012 plus 10 over 2 to the power 09 plus 1. So now we know that the moment they say hence, which means you must use what you have from above. So 2.2.2, we have 2 to the power 2010 plus 2 to the power 2012 plus 10, all divided by 2 to the power 2009 plus 1. Okay, so now let's solve it. So initially we had this. So we can see that you're also given 2 to the power 2010 and also 2 to the power 24. So these two, since we proved that these two, they are the same as 5 times 2 to the power 2010, so we're going to use the same knowledge. Okay, so now coming here in this part, so we're going to have 5 times 2 to the power 2010 plus 10, all divided by 2 to the power 2009 plus 1. Okay, now we can actually solve it. So how can we solve from here? How can we solve from here? So what do we know about 10? 10 is the same as 5 times 2. Okay, so it's going to be equal to 5 times 2 to the power 2010 plus 5 times 2, so that you can have some common factors. Okay, 2 to the power 2009 plus 1. So 5 and 5, they are common factors. So now we can use that factor. Okay, so having that factor now, we can actually also see that 2010 is the same as 2 to the power 2000 2 to the power 9 times 2. So you can see 5 times 2 and 5 times 2, they are there. Okay, so now we have 5 to the power 5 times 2 as a common factor. Then we have 2 to the power 2009 plus 1. Okay, divide by 2 to the power 2009 plus 1. Then this and this will cancel each other. Then our final answer will be equal to 10. Okay, then our final answer is equal to 10. So now let me recap something here so that you don't say that I rushed on this part. So on this part, what did we do? So we said that 2010 is the same as 2009 plus 1. So 2 to the power 2009 times 2 to the power 1, or let me just say plus 1 is the same as 2 to the power 2010. So this can be broke down to be 2209 times 2 to the power 1. So also we can also break 10 to be 5 times 2. So we can actually say 5 times 2 and 5 by 2 as a common factor as here. So we're going to have 2002 to the power 2009 plus 1, or divided by 2 to the power 09 plus 1. Then we get our value of 10. Okay. Now let's do the other question. Simplify this. How can you simplify this? 2.3.1. So x to the power negative 1 plus y to the power negative 1. Now we just apply the laws of exponents. So let's apply the laws of exponents. This is the same as 1 over x plus 1 over y. Okay, don't worry yourself. Then xy is the common factor, so it will be y plus x. So we have solved it. Now we have our 3 marks. Okay, now on 2.3.2, let's look for it. Hence, underline that hence because it's a keyword. Determine the sum of the reciprocals of 2 variables if their sum is equal to 10 and their product is equal to 20. So the sum of these 2 terms is 10 and their products is equal to 20. So these keywords of sum and product is something which is also going to assist us. Okay, so check it out. The sum will then be equal to 1 over x plus 1 over y. Okay, and we also solved them initially and we saw that they are equivalent to y plus x over xy. Then also they say that the sum of the sum of this here on the question, they told that the sum is equal to 10. So the sum of is equal to 10 and the product will be equal to 20. So you can actually see that here these are the sum. Y plus x is equal to 10. This is the sum and the product is equal to 20. So definitely you can actually see 1 over 2. So this question was there to vex you guys, but what is important is to understand the English which they wrote in the concept so that you can actually apply the concept behind everything. Then here you go. Then you can see that you're going to earn your total marks. Now let's look at question number 3. We are getting there. It's the N1 with any question. 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 Great. Now question 3. Consider the following number pattern 3.1. We're having the following pattern: 1 is to negative 3 is to negative 9 is to negative 17. So they are saying that write down the next 2 terms of this sequence. So what is important is that you must analyze, is this a quadratic or is this a arithmetic number pattern? So let's check that out first. So negative 3 minus 1 is negative 4. Negative 9 minus 3, that will be negative 6. Then negative 17 minus 9, that must give us negative 8. So we can actually see that this is not a arithmetic because the first difference is not the same. So since the first difference is not the same, this shows that this is not an arithmetic sequence. Now we go for the second term again now. Negative 6 minus minus 4, then we get negative 2. And we also get negative 8 minus minus 6, that's negative 2. Then that's when now we can see that this has a second constant difference. So since it has a second constant difference, so our mind must know that this is a quadratic a number pattern. So the constant second difference is negative 2. Okay, so negative 2 is here as well. So negative 10 plus negative 2 is negative 10. Okay, so negative 17 plus negative 10 will be negative 27. Okay, then also again we do the same thing. Negative 10 plus negative 2 is negative 12. Negative 27 plus negative 2, that will be negative 39. You use your calculator. So the two values which we need here is negative 27 as well as negative 39. How did you find them? We started by analyzing and finding, is this a quadratic or an arithmetic sequence? So we figure that it's an quadratic sequence since it has a second constant difference. So having that at the back of our mind that it has a second constant difference, so we use that second constant difference so that we can be able to get the following two terms. Okay, the next question says that determine the general term of the number pattern. So the general term of the number pattern, since this is a quadratic term, since this is a quadratic form pattern, we know that let's check this 3.1.2. So we know that Tn is equal to 2an squared plus bn plus c. Okay, what is our a? How do we find a? We know that 2a is equal to d, and our a will be equal to what was our d? Our d here was negative 2, so it's going to be negative 2 divided by 2. Then we get our a to be negative 1. Now we must know the value of b. 3a plus b is equal to t1. What was our a? Our a was negative 1. And now what was our t1? Our t1 was equal to positive 1. Then b will be equal to 1 plus 3. Then b will be equal to 4. Now let's look for the value of c. So for the value of c, we know that it's going to be a plus b plus c is equal to t2 minus t1. Oh, I did a mistake here. Forgive me. This one is not... This one is t2 minus t1. T2 minus t1 here was negative 4. So we have b is equal to negative 4 plus 3. Then our b will be equal to negative 1 as well. So our b in this instance is negative 1. So a plus b plus c, to find c, negative 1 minus 1 plus c is equal to 1. So c will be equal to 1 plus 2. Then we have c is equal to 3. Okay. Then therefore we are not yet done. You cannot say that just because you have the values of a, b, and c you are done. You must write it as a general term. So therefore it's going to be negative n squared minus n plus 3. It's our general term. Then you get your whole 4 marks. Now determine the value of the 30th term in the number pattern. So the 30th term now is the one, the T30. So now where is n, you placed with 30. So also in the general term, wherever you see n, you place your 30. So we have negative 30 squared minus 30 plus 3. Then now let's get our answer. So 30 squared minus 30 plus 3. Then we can get our answer as negative 227. So that's our T30. Now you can actually see that this is easy, right? So we are enjoying, we are cruising together. Which term in the pattern we have the value of negative 7,049 on 79? So now they have given us Tn is called negative 7,479. So what was our Tn? Our Tn was negative n squared minus n plus 3 is equal to negative 7,479. Now let's work this out. So negative n squared minus n plus 3 plus 7,479 is equal to 0. Then we can definitely get our negative n squared minus n, then 3 plus this, then 79 plus 3, that will be 82. Then positive 7,482 is equal to 0. Then we divide all through by negative 1, so that we have negative n squared plus n minus 7,482, which is equal to 0. Then after that, what do? We now solve this, because we can see that this is now a quadratic equation, but it is written in the terms of n. So now let's solve for n. So you can use the quadratic formula, or you can use the factor form. So when you're using the factor form, you can see that you have n and n. So how can we get this? So when we say 87 and 86, then we can get that 740. So must have another one as positive, another one as negative. Okay, so this will be our two factors. This will be our two factors. So I urge you, if you don't know how to find factors, use the quadratic formula so that you can get the correct answer. So in this instance, you are calculating n. So you start by writing your quadratic equation. Then after that, you substitute the place where you see x. Now you put the algebraic letter n, so that you can definitely see the correct solution. Then n will be equal to 86, or n will be equal to negative 87. And also on this one, you conclude that therefore n is equal to 86, because your n can never be negative. Okay, now we're gonna do this last question of the day, which is functions. We're gonna only do this. Let's see what we can do on functions. We're gonna do something nice and fun. So we're gonna do this last question on functions, question 6. Then we are done for the day. Okay, then we are done for the day. So they say the sketch below represents a graph of f of x. Okay, the sketch below represents the graph of f of x, which is negative 2x squared plus bx plus c, where point D is the turning point of the graph. Graph f intersect the x-intercept at point f and q. So you can see this is the x and the x-intercept. So now calculate the values of b and c. How can we calculate the values of b and c? So what do we have initially? We are given that our f of x, come on, okay, here we go. So we're given that our f of x is equal to negative 2x squared plus bx plus c, and we are also given the coordinate d to be 1:8. Then this is the turning point, as they say that. So let's just write this is TP. Okay. Then also they told that P and D, they are the x-intercept of the formula. So this is easy. You can solve this in two ways. Okay. So you can solve this by using an easy way. All right. So the first one is that you can solve it by saying substituting this D value. So when you substitute D in f of x. Let's see. So where there is x, we put 1. Where there is 8, we put where there is y, we put 8. So it's gonna be 8 is equal to negative 2 times 1 squared plus b times 1 plus c. Okay, so now we have 8 is equal to negative 2 plus b plus c. This will be our equation 1. Then we know that p is 0 is to 1. Okay, oh, x is to 0. So wherever we see 0, okay, let's find another way. Let's see something. Okay, let's use this fact, or let's use this fact. Let's solve it using the turning point formula. That will be easy for us. Okay, so f of x is equal to negative 2x minus 1 all squared plus 8. Let's use this fact. Okay, so in order for us to get b, what do? We just expand this. So it will be equal to negative 2 x squared minus 2x plus 1 plus 8. Okay, then now we have negative 2x squared plus 4x minus 2 plus 8. Then we can see that it's negative 2x squared plus 4x minus 6. Okay. Sorry, plus 6. So what did we do? So we saw that we are given D, which is the turning point form. So we can use the turning point equation, which says that f of x is equal to a of x minus p squared plus q. So what was our a? Our a in this instance is negative 2 x. Here we have 1, so it's going to be x minus 1 squared, and our q was 8. So now we just solved this so that we can get the values of b. So therefore b is equal to 4 and c is equal to 6. So we use that format. Okay, now the next question, the last question of the day, they say the graph of g represents f when f is translated 2 units to the left and 3 units up. Determine the equation of g. So let's determine the equation of g. So there are two ways in which you are doing this. So you can use the turning point formula, which here formulated, that says negative 2x minus 1 all squared plus 8. So they say that the graph has been shifted 2 units to the left. So when your graph has been shifted 2 units to the left, what do you do? When your graph has been shifted 2 units to the left, that means that your graph is going to be shifted here and 2 units up. So it's going to be negative 2 of x minus 1 plus 2. So when it's shifted to the left, you add. When it's shifted to the right, you subtract. Okay, then plus 8 upwards. It has been shifted 3 units up, so we add 3. So then therefore we can have negative 2 of x plus 1 or squared plus 11. So this will be the graph of g of x. Okay, so it has been shifted. So the key words here which were here is that it has been shifted to the left and to the 3 units up. So we used our turning point formula, which we have already solved. Then we substitute this value so that you can have the correct values. Hope you enjoyed the session which we had today when we were doing the grade 11 question paper from Gauteng. We did solving for x, we did sets, we did number patterns, we also did functions. Wish you all the best with the exam as you are writing this week. All the best and have a great evening ahead. Cheers.